Okay, so for the first part, we have seen that how we can use oscilloscope and function generator for the AC circuits. Now on the second part, we will use oscilloscope to measure the voltage in this circuit. Okay, the circuit is similar to the previous circuit that we have seen, but however there is an AC source here, and we know that for the AC source we need the amplitude and the frequency. Okay, these are the main thing, and also the wave shape. Okay, here we have sinusoidal with 4 volts peak and 5 kilohertz frequency. We will give this voltage to two resistors in series, and we will measure the voltage across R1 here and using oscilloscope. So oscilloscope, we know that from the previous part that it will measure the V peak value. Also oscilloscope can measure the time period. Also it can show you the wave shape. Okay, and we know that 1 over the time period is the frequency, so indirectly it is also measuring the frequency. Whereas, for example, if I connect, instead of oscilloscope to be connected here, if I connect voltmeter or the multimeter here, so what it will give? It will give you the RMS value, root mean square value. Okay, and there's a special relationship. Like for example, okay, VABP, which is the peak value. If you use oscilloscope, it will give you the peak value. So you measure using oscilloscope and note the reading here. If you instead of the oscilloscope, if you put an multimeter, which is an AC multimeter, not the DC one that we are using the previously. So AC multimeter for the AC values, AC source will give you the RMS value. Okay, but there is also a special relationship between the VIB while using the oscilloscope, and we'll be using the voltmeter, that is the square root of 2, square root 2. Okay, so the okay, and this is true for sinusoidal. Okay, for the other waveforms we have another relationship, but here we are talking about the sinusoidal. Okay, so the ideal value here should come square root of 2. Okay, square root 2. Okay, so and okay, let me now make a circuit here. The same circuit we have, let me check. We have a we have okay, I'm using this resistor. Why I'm using this? Because I can change its value later on, although I don't need to change it frequently, but just to show you that I can also use this green one. The because if you have this one, you have to give the value from there directly. Okay, you can do that, but just to give you another flavor, I am doing this. Okay, so let's see, one is 100 ohms. Okay, and the other one R1, although this is R1, this is R2. In the manual this is the opposite. Let me do that as well. Okay, so this is 150, and the display label is, this is R1. Okay, so let me do that. Two, and this should be 1. Okay, and now I have to put an AC source. So AC source, I go to the sources icon here, and this is the AC source. Okay, and just build the circuit as we did it previously. Put a ground. Okay, now I have to measure a voltage here. Okay, according to the manual, you see the manual, we have to put one end here and the other end here. Okay, so we should do the same, because we have, these are the two channels. Make sure these, we cannot connect A here and B here. This is not the like positive negative, these are the two channels. Okay, so I will connect one channel, the other channel I don't need it. Okay, and the other ground, so ground I will just connect to the ground, another ground I will just place it, and that's it. Okay, so this is the setup. The other thing, this will measure the V peak. Now we have to use the uh, multimeter to measure the RMS value. Okay, let me open them. And here make sure that this is DC. No, we don't need DC, it will not give you any value. Okay, so we have to keep it on AC. So this is the multimeter to be used for AC, and this will give you VRMS. Okay, let me open this. Okay, this okay, fine. These are the previous waveforms that I showed you, so it will be okay. Now you can see there are two problems here. One is the amplitude is very low, so I have to change them. Okay, amplitude become high, however because of this scale it's very squeezed. Okay, so let me, okay, now you can see I just reduce the scale and it becomes clear now. First thing I need to do is I need to measure the peak value. So let's peak is almost like where's the peak? Okay, this is 5 almost 600 or millivolts. Okay, now let me check the values. It's the voltage given was in our experiment is 4 amplitude with 5 kilohertz frequency. Okay, so I have to do the same here. Let me change it to 4, and then the frequency is 5 kilo. Okay, now let me check. Okay, set the scales, and now see it's like 2.4 volts. Okay, and which is the exact value, and the RMS value measured by the multimeter is 1.697. So you can note down this, and the ratio of this will be under root 2 as I told you here, but this is true for the sinusoidal. And what else, let me go back. Okay, here the other thing is, if you want to change if you want to use another waveform, here you cannot, because this is the same. I mean, this should give you the sinusoidal. If you want rectangular, this rectangular is here. Okay, but normally it will not be needed in our experiments. Okay, so I think that's it. I think we don't have anything else to show. Okay, so thank you guys.